This is section 6.4, the triangle midsegment theorem. We begin with a definition of a midsegment of a triangle. A midsegment is a line segment that connects the midpoints of two sides of a triangle. In this drawing, we see that I'm highlighting MP. M and P are both midpoints, and we know this by the congruent marks on each of their sides. And since they're midpoints, when you connect them, you create a midsegment. Every triangle has three midsegments, and if you draw all three of them in, you get what is called the midsegment triangle. So we can begin with a coordinate plane example. Here we have triangle JKL, and it says show the midsegment MN and that it is parallel to side JL. Well, the side that it is parallel to means that it can't touch that side. So we need to find the midpoints of the other two sides. So we'll find the midpoint of JK and the midpoint of KL. So if we take the coordinates of point J, we have negative 6, 1. And the coordinates of point K, we have negative 2, 5. And to find the midpoint, we take the average of the X values and the average of the Y values. And we get a midpoint at negative 4, 3. And if we plot that, we will label that point M for our midsegment. And now we have to do the same thing for KL. L has coordinates at 2, negative 1. So now let's find the midpoint of KL. Take the average of its X values and the average of its Y values. And we get 0, 2. We'll call that point N, and then we'll use a segment to connect those. And now we want to show that MN is parallel to JL. So we do that with slope. The slope of MN is equal to, we can use the coordinate plane to help us, 1 down and 1, 2, 3, 4 over. So that's negative 1/4. And the slope of JL, we can see it's 1, 2 down and 1, 2, 3, 4, 5, 6, 7, 8 over. So that's negative 2/8, which reduces to negative 1/4. And since the slopes are equal, we have shown that these two are parallel. So we've checked off the first task we were asked for. Next, they want us to show that MN is half the length of JL. For this, we need to use the distance formula. So let's begin by finding the length of MN. So we see the X coordinates of M and N are negative 4 and 0. We have the difference of the X coordinates squared. And the Y coordinates are 3 and 2. We'll take the difference of the Y coordinates squared. And now we can simplify our radical. Negative 4 squared is 16. And 1 squared is 1. So MN is equal to the square root of 17. And now we can look at JL. Take the difference of the x's and add that to the difference of the y's. And we see we have negative 8 squared, which is 64. And 1 with a double negative becomes plus 1, so that's 2 squared, which is 4. And that gives us that JL is equal to radical 68. So we can break up this radical into two smaller radicals. Square root of 4 times square root of 17. And the square root of 4 simplifies to 2. And now you see that 2 radical 17 verifies that JL is twice the size of MN, or that MN is half of JL, and this property was verified. Now we go to the midsegment theorem. This theorem states that the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that third side. And we will understand this to be true for all midsegments of a triangle. And we can apply this to some of the problems here. We begin with problem 3, where we're asked to get the coordinates of D, E, and F. And while we're at it, I'm going to get the coordinates of A, B, and C, because we're going to need them all to verify the properties for these triangles and their midsegments. So now that we have these coordinates handy, we can go on and solve problem 4. It says, show that DE is parallel to CB. Well, we want to find the slope of DE. And we can count that in the grid, 2 up, 2 over. That's a slope of 1. And now we can find the slope of CB by counting 4 up and 4 over, which is 4 over 4, which is 1. The slopes are equal, therefore these two are parallel. And the second part is to show that DE is half the length of CB. So we call on the distance formula again. Take the difference of the x's. The double negative turns into a plus instead of a minus. And then the difference of the y's. And we get that DE is square root of 8, and square root of 8 can be written as square root of 4 times square root of 2, which is 2 square root of 2. Now we go on to CB with our distance formula. And we get that CB is the square root of 32. This can be written as the square root of 16 times the square root of 2, which reduces to 4 square root of 2. And once again, we see that CB is exactly 2 times larger than DE, or you can say that DE is half the measure of CB. So you can follow this process for 5 and 6 and show that those properties are true for the other examples as well. And here are some other types of problems you can see with midsegments. So the problem tells us that DE is a midsegment. The midsegment is going to be half the length of the side it is parallel to. So for number 7, x is 13. For number 8, the midsegment is 5. It's half the length of the side it's parallel to, so it makes x equal to 10. For number 9, DE is the midsegment, which means that E is a midpoint. So these two must be equal for that to be a midpoint. So x is equal to 6. And the same thing for 10. They tell us that DE is a midsegment, which would make E a midpoint. So these two halves of side BC must be equal. So x is equal to 8. So in this example, we have xj is congruent to jy. When we see that, that makes j a midpoint. Then they tell us that yl is congruent to lz. That makes L a midpoint. And then finally, they tell us that xk is congruent to kz. That makes k a midpoint. Since those are all midpoints, that means we have a midsegment triangle outlined here in the center. And since these are all midsegments, they are half the length of the side they're parallel to. And we can answer these questions. JK is parallel to YZ. JL is parallel to XZ. XY is the whole side of the outer triangle. That is parallel to the midsegment, so KL. And then, since a midsegment is equal to half the side it's parallel to, and since we know that we're using a midpoint, these two are congruent, but they also have to be congruent to the midsegment because they all represent half of YZ. So when we look at JY, JY is congruent to XJ, but it's also got to be congruent to the side it's parallel to because all of them represent half of xy. So we can fill this in as xj and kl. And now when we look at JL, JL is right here, and that's going to be congruent to xk and kz. And then the last one is JK. JK is this side, and that will be parallel to Y, L, and LZ. So here we have another set of problems. Now we can use some algebra with these problems. They're telling us that A, B, and C are midpoints of each of their respective sides of the triangle. And right away I know that these are all congruent, these are all congruent, and these segments are all congruent. So when AB is equal to 3x plus 8, and GJ is equal to 2x plus 24. What is AB? Well, GJ is the whole side, and AB is the midsegment. So you need AB plus AB to be equal to GJ, because GJ is twice as big as AB. So since AB is 3x plus 8, I can add that again and set it equal to GJ, which is 2x plus 24. And now we have an algebraic equation that we can solve for x. 6x plus 16 equals 2x plus 24. We get x is 2, and now when we plug that back into AB, we get AB is 14. So pause the video, try number 18, and see what you get, and then unpause. So if we look at this AC and HJ, it's the same as what we did before. AC is going to be half of HJ, so we need to account for AC twice. So we can say 2 times 3y minus 5 is equal to 4y plus 2. And we get that y is equal to 6. And now HB is half of HJ, or we can say HB is congruent to AC. I can plug in 6 for AC. I get 3 times 6 minus 5, which gives us 13. So HB is 13. And again, if you want, you can pause here, try the next one on your own, and then unpause. GH is the whole side of the triangle. CB is the midsegment, which is equal to half of GH. So I need to count for CB twice. So Z is equal to 5. And they want to know what GA is. GA is half of the side of the triangle, which is congruent to CB. So GA is equal to 4 times 5 minus 3, which is 17. So that's the end of the presentation. Watch it again, take notes, and come to class with questions.